Scores already in Blackboard. You can check on that one in there. Okay, ready? Okay, let's thank you. Let's work on our estimating a population proportion. So we have the following in here. P hat, that is the point estimate of population proportion, can be equivalent to once again what we have in the past, actually 8.2. How many respondents has that characteristic over the sample size? Okay, so that basically is our population proportion point estimate. Let's consider this one in here and see how we can get that what we call point estimate as such. Let's read this one first. Giselle, go ahead please. All right, obtaining a point estimate, population proportion. Giselle, were you able to see that one in there? The what's this? Federal income tax. Okay, which if you were like employed, then you must have filed that one before April 15. All right. Okay, let's read this one first. Thank you.
The Gallup organization conducted a poll in which a simple random sample of 1,013 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay is too high? Of the 2015 adult American survey, 458 said yes. A 2-point estimate for the proportion of Americans 18 and older believing the amount of federal income tax they pay is too high.
Thank you. Okay, so once again, using our formula, then that means our point estimate for this population proportion is equal to, once again, X over N. X will be the number of respondents who has that characteristic, right? So in here, what is that characteristic? What is the mentioned characteristic in here? They mentioned
the ones that say yes?
They said yes to what?
The federal income
The
tax
federal
is too
income
high.
tax being too high for them to pay, right? What do you think, guys? Is it too high for you? Actually, it depends on the state as well. Some states have different conditions for those. Well, actually, that's for the state income tax, right? But for the federal, I think it's like across the board. Like all of the states have all of the states will have the same federal income tax. Anyway, in here, how much is that gonna be? Anyone? How many has that characteristic?
458.
458, very good. Over, how many were sampled in here? 1050, very good. All right, so as simple as that one, that will be our P hat in here, or the population proportion of that characteristic, who are what? Saying that it is too high for them, this federal income tax. Okay, so which we have done already in the past. Now let's consider now what we call the confidence interval, okay? And how do we use that confidence interval? Let's read this one first. What do you mean by confidence interval? 3, let's read that one, please. Thank you.
A confidence interval for an unknown parameter consists of interval of numbers based on a point estimate.
Thank you. So this is our point estimate in here. By the way, this is the population proportion mentioned already. So the point estimate will be somewhere in here as well. The question now is, what are the chances that the point estimate will be within this frame? Okay, within this confidence interval. And what is that confidence interval? It says in here, mentioned in here is how much? 95% confidence interval, right? So when you say 95% confidence interval, then that means this lower bound and this upper bound, if we cut this towards the middle, right? So which means, what's 95 divided by 2?
48.5 maybe?
Okay, calculator. There you go, thank you. Okay. Oh, what you got?
47.5.
47.5, almost there, right?
Almost,
Just
yeah.
one point. Okay. So when you say 95.2, then that means, again, it is 47.5%. So that means this in here is what? 47.5%, okay? Because that mean splits it into two, right? It's a normal distribution. This another one in here is 47.5 as well, right? Which means, how much is this in here? This one in here.
2.5.
Would it be 2.5?
So it's 95% confidence interval, right? So
Yes.
that is 5%. This two will be equivalent to what? 5% divided by 2. So that means this is what? 2.5%. And this will be what? Another 2.5%. Did we get it right, guys? Okay. So which? Okay. So with that being said, what now? What now is the z-score corresponding to that one in there, right? So to get the z-score, we can use StatCrunch. We can also use our z-table for such. So let's use our z-table first for now. If we go to this one, go to what our z-table. Again, on our z-table in here, it says what? This is area to the left of the z-score, right? So if we go back to our problem a while ago, okay? So to go back to our problem a while ago, how much is this? This is 95%, right? But it says a while ago to the left, right? So how much is this again? 2.5. So what's this? 95 plus 2.5. The whole area to the left.
97.5.
Thank you. Okay, very good. So this entire area to the left, this is 95%. This is 5% to the rest of them, but since this is two-tailed, that's 2.5 per side. Okay, so that would be, what's this again? 95 plus 2.5, how much is that? 97.5. Okay, the area to the left is 97.5. Why are we doing that? Because a while ago it says our z-score is what? Area to the left. So when you say to the left, that includes that because that's also to the left. Not only the 95 but also the 2.5. So how much is this? 0.975. Alright, so let's see now. What z-score corresponds to that, right? 0.975. Let's verify. Go back in here. And let's verify in here. Where is that 0.975? Let me just go ahead and move this one in here. We know it's more than 50%, so we know it's a positive z, right? It's to the right. And let's see, where is that? 0.975. So which one in there is nearest the 0.975 interval? Let me just go ahead and X this out. And see in here from the z-table, we're looking for a value that is nearest 0.975. Where is that? 1.96. Very good. So that's 0.975. There. See that one? Exactly. Well, honestly in here, it's just a rare occurrence that it became exact. If it's not exact, what are you going to do? Choose the closest. Okay, so what's that? 1.96. That is the z-score equivalent for that. Okay, so if I go there and see that column of 1.975, I would see in here that that is that. Okay, 1.96. Okay, get it, guys? Okay, and actually, if you verify in there, if we go back in here once again, let me put it in back in here. So this z-score in here, z at what, okay, 95%, okay, divided by 2, right? This is what, 1.96, okay? So verifying in here on the other end, what's that gonna be? 2.5%, right? 0.025. If I look at 0.025, what's that gonna be in here? Okay, so this in here is what? 0.025, right? So where is this one? 0.025 for such. So as you may notice in here, oh, here we go. Just went exactly there, right? Okay. 0.025, that is negative 1.90 what? 1, 2, 3, 4, 5, oh well, 0, 1, 2, 3, 4, 5, 6. Negative 1.96 as well, right? So with that being said, to the right is 1.96. To the left should be what? Similar, but negative, right? Z of 0.95 divided by 2 in here is equal to negative 1.96, right? So, and that should be what we need to get, however, okay? Questions, guys, with what we did with that? Also, you can use our StatCrunch for such. Mr. Deal, how do we do StatCrunch for that, right? If we go here, let's go to open our StatCrunch. Just go to StatCrunch. You know what? It doesn't really matter what we open in here. We just need to get the we just need to get the calculator. Okay, so how do we do that one in our calculator? And here it is, okay? Select, what's this? Okay. Select stat, here it is. Let's go to calculators. Yeah, let's go to, what's this, normal. Okay. For it to be standard, I'm gonna put in here 0 and 1, right? Okay, 0 and 1 for such. And then, it says in here, if given the area to the left, we click on this, right? So if we click in here, so again, we click on mean to be 0 and standard deviation to be 1 because this is standard normal distribution. To the left, it says how much? 0.025. So I'm gonna put in here 0.025. Okay, click in here. Oh, sorry. I'm gonna put in here. It's the area that we need to put in here, right? 0.025. And that's what we got. Negative 1.96. Okay, so even without using a calculator, without using the Z table, you can just use the calculator in here because it says the area to the left is 2.5%. So that's 0.025, right? If you want to see the area to the right, we're going to do the same one as well. So if it's to the right, I'm going to click in here and do the same in here. 0.025, okay? And if I see in here, I got the same value, 1.96, okay? So depending on whatever you use, Mr. Deal, I don't have my Z table. Well, if you have StatCrunch, you can do that one as well, just using the calculator, right? Mr. Deal, I don't have the StatCrunch. Well, you have the, if you have the Z table, then you can get it from there as well. So just depends on what you figure out what to do. Either of those will be the same. It's just that on a Z table is always to the left. Okay. However, in here it can be to the right. Okay. So if you are given the probability or the margin of error or the level of confidence, you put it in here and it's gonna compute for the Z for you guys. Okay. Questions? Okay. Now let's use that one to answer some more questions in here. Okay. This table values in here would give you the most common confidence intervals used for researches, okay? The 99% level of confidence typically is used for medical researches because you want it to be stricter. So if it is to be stricter, then your level of confidence is 99%. So in short, the tails or the margin of error will just be what? Half a percentage, right? Half a percentage to the right and half a percentage to the left, okay? And how much is that gonna be? 2.575. Is it on your notes, guys? See that one in there? Okay. A while ago, we said 95%. So when you say 95%, that means what? 5% margin of error, right? That means that's the outer. Which means, if it's 5%, it's two-tailed. Then on the lower end and the lower bound and upper bound, 2.5% each, okay? And lastly, this is a moderate level of confidence, 90%. But typically, the 95% is used for social science journals or researches. Like if you do want to do like an intervention, like of an educational nature, typically it's the 95% confidence interval. But typically, if it's like a medical procedure, medical medications or new medication, typically it's a higher level of confidence, definitely, because we're talking about like health sciences for such. Okay, 90% is typically not used because in terms of strength of the or power of the results is not that acceptable. Okay. However, the 95 and 99% are good indicators of the strength of the level of confidence. Again, this one you don't need to memorize this one. You can basically just go see the Z table and use your StatCrunch or both. You can do the same, okay? So, how do we use those? Let's see. All right, let's read this one in here and see how we can work on this one, okay? Let's read them here. Interpreting a confidence interval. Let's read this one. Caroline, go ahead, please. Able to see that one in there? Still the same, the federal income tax being too high, right? Okay, go ahead. Thank you.
When the Gallup organization conducted the poll, introduced.
Example one, yeah.
45.1% of those surveyed considered the amount of federal income tax they had to pay as too high. Gallup reported its survey methodology as follows.
Okay.
Results are based on cell phone reviews with a random sample of 1,015 national adults age 18 and older. For results based on the total sample of national adults, one can say that 95% confidence that the maximum margin of sampling error is 4 percentage points.
Thank you. Okay, continue. Determine and
Determine and interpret the confidence interval for the proportion of Americans aged 18 and older who believe the amount of federal income tax they have to pay is too high.
thank you. Okay, so with that being said, it says in here, what is 45.1? Okay, what is the 45.1 in here, guys? 45.1 percentage, that is the what?
People that say it's too high.
The sense is too high, right? So basically that's your what? P, right? So it says in here, did we get 45.1 a while ago when we, let's see, let's verify. 1015 divided by, on problem number 1 a while ago, it says out of 1015, how many did say yes? 458, right? 458 divided by 1015, we got 45.1%. So that is correct. That is our p hat, 0.451. And again, we got this one a while ago from, we said how much? 458 over 1015. Okay, and that is the sample size. Okay, now in here it says 95% confidence that the maximum margin of sampling error is 4 percentage points. So with that being said, we can verify that one by drawing a normal distribution curve like this one. Okay, so with this being said, then this one will be what? So this is what? 0.451. Right? So that means this one in here is what? 0.451 plus 4%. Okay, go. And this one in here is what? 0.451 again, plus, not plus, but minus instead, right? Minus, 4%. And it says that this in here will create how much? A 95% confidence interval, right? So that is our lower bound, and this is our upper bound. Okay, which means, that basically means that what? That we are 95% confident. Okay, again, we are 95% confident that whatever sample proportion it will be, right? Based from a simulation of these, how many times this will be done, or this research will be done, we are 95% sure that that point estimate will be within this interval. Okay, so that will be between what? 0.451 minus 0.04, what's that? 0.451 minus 0.04, 411. That means what? 41.1%. And the upper bound will be what? 0.451 plus 0.04, which is how much? 0.491, which is 49.1%. So again, what this means is, if we redo this, okay, if they do simulation of this several times, say 100 times, if they do that simulation 100 times randomly, then 95 out of 100 times that they do this research, the proportion of those who would say yes to the federal income tax being too high is within this interval. Good. So it can be less than 45.1, it can be more than 45.1, but it will be within this bound, lower and upper bound. Are we good, guys, with what we dealt with that one? So let us use now some of the formulas for such, and here are the formulas for this one in here, okay? So we got in here the following. Depending on the confidence interval, we always divide it by 2. Okay, why? Because whatever your confidence interval is, it'll be two-tailed, right? So you split it into 2, and that will be multiplied by the standard deviation of the population proportion. Okay, and we recall, what is that standard deviation of the population proportion? If you recall in 8.2, this is the formula for that, okay? This in here is the what? Standard deviation of the population proportion, right? Square root of p hat all over times 1 minus p hat all over n. You multiply it by what? The z-score at alpha over 2, right? So we just verified a while ago, if it's 95% confidence interval, what's your z alpha over 2? 1 point. For 95%, guys, what did we say a while ago? 1.96, right? Okay. Verify on your table or the statistics calculator as well, right? Verify here. This is what we mean a while ago, okay? If it's 95%, that's 1.96. If it's 99%, then it's 2.575. And again, we can verify that one using our calculators as well, or the z-table itself, right? Again, it's just that the z-table will always be area to the left, okay? Going back, let's see in here and use that formula to solve some questions in here. Here it is. Okay, let's go to our practice exercise and do this one in here, okay? Yeah. So what did you say on our lesson 9.1 practice, guys? What did you say? Let's read in here. Number 9. What did it say here? Number 9. What did it say? 98%. What did it do with that? %. Okay, what does it mean? What do we do with this? Determine the what? Angelina, let's go ahead and read that one, please.
It says, determine the critical value,
Z what? Alpha over 2.
okay, Z alpha over 2 that corresponds to the given level of confidence.
Thank you, alright? So when you say critical value Z alpha over 2 for 98% confidence interval, first of all, what is your alpha for that? What is your margin of error for that? So if it's 98%, what is your alpha? 2%. Very good. Okay, so that's 2%, which is basically 0.02. However, we want alpha over 2 because it's going to be split onto the left and to the right, right? So that means your alpha over 2 will be what? 0.01. Good. Right? So we can verify that one. Draw, right? How do we see this one, Mr. Deal, right? So this is our P, population proportion. So the estimate is 98% level of confidence, okay? So that means in here, there is how much in here? 1%, and there's another 1% in here, which in decimal is what? 0.01, okay? Okay, so on our stat crunch, we can put the same in there, right? What's the probability of your X being less than that value such that the value to the left is what? 0.01. Okay, so this is for this. For this one in here, you can write it as such. The probability that your X or the Z score is what? Greater than, right? Because it's to the right, okay? Greater than what? That question mark is again 0.01. Okay, well, let's verify. Again, Z table or stat crunch, any of those two will be fine, okay? Let's do our Z table, 0.01. So if I go to my Z table, here it is. Where is that 0.01? So which one is the nearest to 0.01, guys? If I look in here, 0.01072, is it the nearest? Oh, okay. So just choose between these two, right? Okay. So is it 0.00990 or 0.01017? Okay. So if I choose this one, that's what? Negative 2.32. Okay. If I choose this one, 0.009, I think this one is the nearest, right? Yeah, there we go. Because this one is, yeah, this one is the nearest, I would say, negative 2.32. Okay, so that's it. If I use my stat crunch, I can do the same as well. Go back in here and put in here what? 0.01 for the right side. If I click in here, 2.32 as well, which is what we got a while ago, right? Let's verify in here. Is it 2.32? Yes, it is 2.32 as well, right? So we can verify in here that that Z score is equal to 2.32 plus or minus, okay? Plus to the right and minus to the left, okay? So tomorrow we're gonna continue with some more of those formulas to use for such. And again, that is our Z alpha over 2 that we're gonna use for whatever level of confidence we are targeting, okay?